going to be able to put some vocabulary in here for you today, so you want to make sure you get that down. But 1.3 is going to start our cross sections of solids. We're going to be taking solids like you see over there on the table over there in front of Gabriel, and we're going to be looking at cutting these up and seeing what shapes are formed. Okay, you guys have all cut a slice of cheese before, haven't you? Off of a block. Sometimes it depends on how you cut it, but typically, what's the most common shape you get when you cut those slices of cheese? Typically a rectangle, and if you kind of think of it, just keep continually slicing the same way, those are the type of shapes that are going to show up after you continue to slice this. So, guys, in 1.3 right here, cross sections of solids, our essential question. Do I have a volunteer to read our essential question today?
How can you use a piece of food to create a real-life cross-section?
Okay, so how can you use a piece of food to create a real-life cross-section? Okay, I kind of think of like a piece of cheese, and it doesn't matter. You can get a rectangular brick, but you know, just think about like that cake that we cut. When we had that cake with the cylinder over there, if I cut straight down into it the first time, if I have a round cake like I have right up here in front of me, if we cut straight down into it and then we can pull this apart, what new surface on the inside, what's the shape of the new surface on the inside that's formed? You would tell me it's a what again? It's a rectangle going around there. Okay, so again, you know, it doesn't necessarily need to be food. It can be any salad that we're talking about. So today our goals are to describe cross sections. We're going to look at sketching some cross sections, and then we're going to solve some real life problems involving cross sections. First thing I need to do is get some vocab in here. I forgot to type them in, so let's do that quickly. First term that we're going to have is, what is a cross section? So get that in the first box. I need to change the font here, obviously. Squeeze that up in there. Okay, so cross section is my first one. Right? Next term we're going to have here will be plane. Oops. Next one will be, I can't remember. I think I should know this right here. We've talked about this a lot already. Pythagorean Theorem. And then square root's my last one, okay, kids? All right, so get those terms in there first, okay? All right. I just got that floppy out of here. It's gonna be aggy. All right. Cross section is going to be what's known as the intersection of a solid and a plane. Okay, it's going to be the intersection of a solid and a plane. In other words, when a flat surface cuts through a solid, what shape is formed? So it's going to be known as the intersection of a solid and a plane here, okay, kids? Intersection of a solid and a plane. Okay. You guys know what a plane is, don't you, in mathematics? Describe to me where there's a plane at in this room.
The wall.
The wall, assuming it is, yeah, it's flat, right? Okay, so basically a plane is going to be any flat surface. Okay, it's basically the surface that's formed after you cut something up. So like when we cut our cake earlier here, that cylinder was our cake. part that forms when you pull them apart, the flat part that's on the inside, that's called the plane. It's going to be a flat surface in there, okay? Pythagorean Theorem, do I need to write the formula for you, or do you know it? A squared plus, so it's going to involve what kind of triangles? What kind of triangles do we use that formula with? What angle has to be present? Right angles. So that's present and right triangles, okay? And then you know what square roots are, so I'm just gonna remind you to make sure that when you solve Pythagorean theorem, if you're solving for A, if you're solving for B, if you're solving for C, make sure you take a square root in the end to get a solution here, okay? All right. Let's see if we can't figure out, I think there's, 3 examples to go through in the notes today? Something like that. Does that sound right to you guys? Very short today, so I think that you'll have plenty of time to get started on things and see things and ask questions. I do want to get into your big ideas a little bit because I think there's some visuals in there that can help you out, so we'll kind of explore around that a little bit today. But let's just talk, kids. Let's talk describing cross sections. We kind of talked about this already. Up here, in describing cross sections here, it looks like, what's this solid right here? What's this solid here on the left look like first, kids? Okay, so the solid is a hemisphere. And we are choosing to take this flat plane and cut from the very top. We want to cut from the very top straight down right here with this. This flat plane is going to cut straight down into this, okay? Now, kids, when I cut straight down, it cuts that hemisphere into 2 equal parts. And the part that's formed right here, or the cross section that would open up in the middle, is right in here. Kids, what shape is that when I cut that open then? So the cross section is a what here, kids? It's semicircle, right, Jaden?
Yep.
I agree. Okay. So the cross section would be a semicircle. Very good. Okay. This next one, what kind of prism do I have right here? What's the base shape on this? What's the base or what's the bottom shape on it? It is a pentagon. So the solid here is a what we call Pentagonal Prism. Okay, so the solid is a Pentagonal Prism. Kids, we're going to take this Pentagonal Prism and we're going to run a plane horizontally through here. Okay, so I'm going to cut this way. All right, make a big old swipe cut. If I cut that in half and pull the top from the bottom, what flat surface is going to be exposed when I pull them apart? What shape is that cross section going to be, in other words? What is it, Maddie? You bet. It's be a pentagon. Okay, yeah. I mean, when we cut through here, shape that's formed is here. Gosh, looks like another what, kids? It's a pentagon. So we'll say the cross section here then, kids. Cross section is a pentagon. So if I ask you to describe the shapes after we've cut through something with a plane and tried to pull that apart and ask you what cross-section shape is formed from cutting that solid, can you handle that part so far? Okay, that's not too difficult, is it? All right, questions on the front side at all, kiddos? Then let's take a look at the back here, all right? Take a look at the back. Says using example 2 here, drawing a cross section here, and I'm going to help you here. I forgot to put a line in here, so we'll have to put that in there. It's hard, I don't know how to do that there. But it says, use the figure in example 2. It says, draw the cross section formed by a plane, flat surface perpendicular to the what, kids? Base. That intersects the red line segment. Draw on the square pyramid what shape of the cross section is formed. First thing I need you to do, put this line in here, kids. And try and make your line as straight as possible. I'll do my best as well. So I'm going to put a red line right in here, kids. Like so. I'm going to change the size on that a little bit. That's kind of... Okay. There's my red line right there. All right? First of all, do you agree the shape that's up there is a square pyramid? All agree with that? Okay, meaning the base is square. Okay, so what I've done, I need to clean this up here if I can. Possibly give me a second. Okay. Here is my red line on this pyramid that I have in front of you up here. Okay. And it says we're going to take from this red line, let me draw this quickly. Come on. Doesn't show up the best, does it? Can you guys see that red line on this right here?
Yeah.
All right. What it's saying is this. It's saying that from that red line that you have right here, you're going to make a cut such that that cut is, and I want to underline this, perpendicular to what, kids?
Base.
It's perpendicular to the base right here. Okay? Describe to me where the base is in that pyramid again.
Square.
It's a square bottom, right? So if I'm cutting perpendicular to the base, am I cutting up and down, or am I cutting forward to back, or front to back, I should say? Careful, I want to be perpendicular to this base, so I should form a 90-degree angle with the base, right? So where this line is at, I'm basically going to come and chop right where that line is, straight down and hit that line. So here's what this is going to look like. Anybody see where I put that rubber band at again?
It's on the one thing.
Oh, it's on the one that I started with. Good, good, good. You guys, this is what happens when you get old. You forget. So I'm going to take this right here. I'm going to put this right up here like so. I'm going to take this and kind of put it like so. And I think that this is what a cut should look like as you say, all right, here's my shape right here. Okay? You guys agree that if I would cut right here at that line that they're indicating, it says what to the base? Perpendicular to the base. Okay? How about somebody in this row describe the outline of this rubber band that's formed right here if I cut that at a perpendicular to the base? Can you guys kind of see the outline of the rubber band around this? I heard a pretty impressive word. What was that again?
Trapezoid.
Oh, what is the weight?
The trapezoid.
It's a trap, isn't it? Yeah, it's a trapezoid. You kind of see it because it's here and it's parallel sides down here. These bases are obviously different lengths, aren't they? But they're going to be parallel to each other, and these sides are going to be slanted, so definitely a trapezoid. So if I had to ask you guys to sketch this in here, here's probably what I would say to do. You're exactly right. We have to understand that our cut's perpendicular to the base, so our cut has to be 90 degrees apart from the base here. So the easiest way to draw this, kids, is say, well, here's my top line. This is really going to be my bottom line right here, isn't it, kids? So really, you're just going to follow the two endpoints of the parallels. Guys, when you sketch that right there, does that look like, well, I'm going to back up on it. I don't like that. Did I put this line in the right spot right here?
No.
Why
It needs to be
not?
back more.
What's that?
It needs to be back more.
Yeah, it should be right below it here, right? There's no way, this is still on the same lateral surface right here, so we can't have that, so that's not going to work. So, Jaden, it sounds like to me you're suggesting take where you drew first person and move it maybe right underneath it, like maybe right about here. Is that what you're saying, kiddo? All right, give me a second. Like so? Is that better? Give me some sort of sign that you're all alive right now. Is that better?
Yeah.
Okay. All right, and then I want to draw this here and this here. And I should have made them all the same color, but you get the idea kind of. This is difficult to draw up here a little bit with this. But what shape appears to have formed here, kids? So if I'm on this line for this square pyramid right here, and I say we're going to cut perpendicular to base, so my cut needs to be vertical. If I would cut this and I could pull this out, what cross-section piece would you see again with that rubber band?
Trapezoid.
Be a trapezoid. And that's going to be the types of things we're going to look at today, and you're going to be asked to describe, say, okay, here's a solid, and I think that you should always start by saying, this is a solid like we did on the first page. I think right here, you should say, well, this is our solid. And when we cut this either vertically or horizontally, that's what's formed for our, what's the phrase here?
Cross-section.
Cross section. That's everything we're trying to do. What cross sections are formed when we cut something, okay? So let's tie this back up here. What shape, let's answer the question. What shape was the cross section here again then, kids? This is going to be a trapezoid. So I'm gonna word it this way. The solid was what shape to begin with, kids? What base down here?
Square.
Is a square what? Prism or pyramid?
Pyramid.
Okay, is a square pyramid. Solid's a square pyramid. That's number one. So then we had to also understand, did we have a horizontal cut or a vertical cut if you were perpendicular to the base? How did we cut this? Did we cut from front to back or from top to bottom? Top to bottom. So that cut was a vertical or horizontal? Vertical. Good. Okay, so the cut, which is really your plane that you're using to intersect your solid, your cut is vertical. So to answer the question, what cross section did we get here, kiddos? Cross section was a, I couldn't hear you guys. What was this cross section again? Trapezoid right in here, you bet. Okay, cross section was, and I should say not was because it still is, trapezoid. Okay, what do you think? So far so good? Okay. I'm gonna let you guys talk this one over a little bit, and then we're gonna come back as a group and see where we're at. Any questions up to where we're at right now? Okay, let's put this stuff into action. Okay, let's just kind of talk about this. I need to get a width or a length put on this for you. Okay, what you need, kiddo? Did you find him? Okay. All right, it says right here, a machine at a sawmill is going to cut a 4-inch by 4-inch piece of wood lengthwise along its, what's the word here, kids? Okay. It says find the perimeter and area of the cross section formed by the cut. One thing we need to do is we need to get a length to this. Okay. So let's do this. What do you want to call it? 20 inches, is that okay? All right, so let's put that in there. That's one dimension we don't have, 20 inches. All right. Take a look at that. First of all, what are we asked to find?
The perimeter of
A perimeter and an area. So let's jot this down at the bottom. We know we're looking for a perimeter. And we're looking for what else, kids? Okay. We're looking for a perimeter and an area of what?
the cross section formed by the cut.
Cross section formed by the cut. So we're going to take this apart is what you're telling me. Okay. You know what I was really good at as a kid? I was really good at taking things apart. You know what part I struggled with as a kid? Anybody else have that problem? That's okay. That's okay. How are we cutting this piece, kids?
No, horizontal.
Read it again. What do you think diagonally is probably assuming here? Or what if I had to say cut this thing diagonally, what do you think they're saying to do? So from one corner maybe to its, what's another word for,
Opposite.
who said that? What?
Opposite.
Yeah, maybe from one corner to the opposite corner. I think that what they're saying right here, kids, is this. I think they're suggesting, hey, let's cut right here. Oh gosh, this thing's not calibrated very well. Try harder. That's even a little better, but let's make it right. I think they're saying cut that diagonally like so. Would you agree with that? Okay, and I think they're saying we're going to take that cut and we're going to take this and go all the way back this way. And then we're going to be diagonal back here. Kids, if I outline what I think we're supposed to cut there, what shape appears to be formed from our cross section? A rectangle. Okay. Here's a question then. Thinking of perimeter, remind me what perimeter is again, kids? So distance around something, okay? Is it possible that I know this length right up here already?
Yeah.
It's 20, okay, because it's the same as this down here. So I know we have a 20 up top and a 20 on the bottom. Okay. We need to find these two short sides of the cross section now, here and here. Suggestions.
Would it be? Oh.
Who's going? Was that you, Anna?
No, I'm trying to figure it out.
Jaden, you good again?
Could
So-
you use the Pythagorean Theorem?
Yeah, that guy. He's kind of important, isn't he? Pythagorean Theorem. What makes you think you want to use that?
Because you need to find the side length, and it would be 4 squared plus 4 squared equals that length, the diagonal length.
I like your reasoning. So we assume when we go to the lumber yard to pick up stuff to build a shed maybe or something like that, we assume that all those angles on the corners of our 4x4s would be what angle? I hope they're a right angle, okay? If that's not right, then you aren't going to have things be square, and anybody that works in construction gets frustrated when things aren't square. I have a bunch of people remodeling my house, and I'm pretty sure it's a good thing that I'm not there to hear them, because I don't think there's a square angle in my house, so they've had to adjust with stuff like that. But yeah, I like this. I'm gonna take this part right out here from the front. I'm gonna go ahead and just draw a cross, or maybe what we see here. This is half of the 4x4, and this is kind of like the diagonal cut that we would make right here. And you're exactly right, Jaden. That's great. You bet. We have to use Pythagorean Theorem here to find this diagonal right here.
32.
Okay, so you're ahead of me. You've gone 4 squared plus 4 squared. Let's see, are we looking for, is the diagonal like the hypotenuse or the leg here then, kids?
Hypotenuse.
So I'm going to call this C based on our formula. So you have 32 is equal to C squared. Let's go nearest tenth on that then. Whoops, I forgot my equal sign. So root that out for me, somebody. 5.6. Okay, so we're going to go ahead and we're going to say that, you know what, this diagonal C right up here, C is approximately 5.6, okay? And it looks like we're measuring in what unit here, kids? Inches, all right. So that makes the diagonals 5.6 inches after we go ahead and we cut that diagonal to form that new cross section that opens up in the middle there. Someone I haven't heard from yet. Someone I haven't heard from yet. I can find a perimeter now. This side of the room. Again, what shape was formed from your cross section? Look at the outline. A rectangle, right? Okay. Rhett, help me through this. To find a perimeter, what are my two longest sides? 20 and 20. Okay, what do we come up with for diagonals then on that cross section? 5.6. Okay, my north of Highway 3 math is going to tell me that's probably about 51.2 inches. Is that going to tell you that? Okay. Okay. How are you going to find the area now? How many square units did you open up on the inside there from that cross section? How much, Jaden?
112.
112. How'd you get that?
5.6 times 20.
Yeah, it's an area of a rectangle, right? So it's just going to be a base times a height, or a length times a width. We know our length is 20, and really the width of this cross section is, what'd you say, 112, is that right? Boy, I did a pretty good job labeling perimeter. What would be the appropriate units for area here, kids? Square inches. Very good. All right, here's a quick question. Can you identify a solid in the cross section that's formed when you have a plane that intersects them? That's my first question.
What was it?
Can you identify a solid? In other words, what kind of solid is this? Triangular prism. Okay, that's the first thing. Can you identify a solid? Identify this whole thing. Then a plane intersects this. Maybe this cuts through like so. Maybe this cuts through like so. My question then is, when that plane intersects that solid, what cross section would be formed here then? Maybe, can you see the outline of the rubber band there okay? Or maybe it's better this way, I don't know. Can you guys all see that over here? What shape is formed from that plane intersecting the solid? Cross section would be a rectangle, very good. Okay. Then, can you take this idea of the shape that's formed and attach dimensions to them to use that to find perimeter and area of cross sections? Kids, if you can handle those things, this section will be pretty easy for you, I think, okay? Let me ask you this. Prior to what we looked at, this easier or way more difficult?
Way easier.
Way easier than what we've been looking at, okay? And you guys, I think, should have a pretty good handle on this based on the quizzes that I graded yesterday, which I'll hand back in a little bit. Questions about anything here before I turn you loose on some things today? Anyone? Guys over here, good? Taking it all in today? Hey, you two good? Stay here? How about my row here? All good? Okay, let me stop this here quickly.